So I'd like to introduce Arndt from Syngenta. You know the drill now, right? We're in a
Can
good
you
way.
hear me well? Very good. So my favorite movie actually is Terminator 2. And yeah, it's a brilliant. I was still much younger than now when I watched it. So there is a lot in it actually, right? So it was actually one of the first action movies where you move from this stop motion animation to computer animation. So already at that time I was blown away actually what virtual reality you can create with a computer and how real this looks like. And of course, nowadays, as we talk about artificial general intelligence, I think the social message, right, what this means for society, is also very relevant again. Though I'm not this topic. I hope the outcome for us will be a bit different. But yeah, so actually, for my background, I'm computational chemist. I worked in data science for chemical research for some time. Got very frustrated with data, so changed into IT to build data capture in a better way, which is what I'm still doing in Syngenta, so in research and development IT, where I am looking for lab automation and our product technology functions. And what is between you and your coffee break is a talk about from automation to adoption, scaling digital workflows at the cyber-physical interface. So what will this talk be about? I will start with the very general problem, right? We have a lot of physical assets in our laboratories, and that can be very diverse, from analytical measurement equipment towards IoT devices or image capture and so on and so forth. And we already talked a lot about data, right? So we want to use this, we want to turn this into data products to fuel use cases that then bring business value. But actually, starting with the technology perspective, operationalizing automation in that space is a socio-technical problem, which I will talk about as well. And actually change and managing that change is key to unlock this. So what do we mean? Again, this is a very general problem. We have a lot of physical assets in our laboratories, right? We invest a lot of money into our hardware. So we really want to leverage that data at scale. At Syngenta, we have something we call digital automation strategy. So it's really how do we bring this data into a digital state that we can also further automate the digital space. And this builds on three pillars, right? Automated data capture. So this is to start with, get your data from the physical world or what your physical world does into a digital state. Then you can build actually workflow automation on top of that, which then improve processes. And this is where Terminator comes back. Of course, we hope that at some point we can only not automate workflows, right? But then we can put automated decision making on top, so AI and so on and so forth, and move more towards closed loop experimentation. And I think the potential from this is quite huge. Now, you should have told me P. before, right? I sent you my presentation yesterday night. But starting with the technology question, right? This is not everything, right? We also now have technology people process data, right? So I guess I have to replace this with organization in the future, but for now I stick with process. I mean, I started with the technology lens, right? But once the technology is working, the problem is shifting, because the best technology doesn't bring you anything if you don't have people that use it. So it's a lot about enrolling people, bringing the right skills in, upskilling, adoption, and so on and so forth. And then also to really get the maximum value, if you have a new technology, you need to rethink your process. If you do lift and shift, you don't win much, right? Because the real question comes, if you have a new technology, how can you leverage this with really rethinking your process from scratch? And now we are adding data as well, because data is the foundation for everything, right? Even if you have technology, people, and process working, if you don't design your data right, and we heard this in the talks before, you don't realize the full value because good data compounds, right? And that's what you need at scale. Now, so much to the theory. I wanted to run through this at one application, which is computer vision for phenotyping. So which is not really new, but actually where we have gone through the whole process basically end to end, right? And the problem statement here is, and I mean, it is still done, but this was the main way of operations like 6-7 years back. How did you do assessments? So we do crop protection, right, in our experiments. So those are mainly greenhouse experiments. So we had scientists walking through the greenhouse, looking at plants, taking some notes, and later adding this into a lab journal or so, right? And because this is very laborsome, takes a lot of time, you know, you do an experimental observation maybe once every 7 days or once a day, depending on your experimental setup. And the hypothesis is that actually with image capture, you can automate taking the images, but also with computer vision, you can fully automate getting experimental results out, right? So to have the computer do the evaluation. And of course, by now we have proof, but we started with a proof of concept. Does the technology really deliver results, and are the outcomes of good quality? Because of course scientists claim, you know, computer vision models, they are heuristic, you never get the same results. I do this much better. If you get this challenge, and you will get it in different AI areas, do an experiment and compare different scientists, and then you will win. It's easy to show that actually if this works, the consistency is much better, right? So we did those proof of concepts, actually successful, so we knew that the technology was working for the problem, but this still does not help to bring this into large-scale operations. So, you know, for these computer vision approaches, training data is needed. You still need to validate what your computer predicts. You need model life cycle, ownership, and so on and so forth. So you need to transition from a proof of concept into a operating model on a platform. And technology platform here, I mean, you need to make this method really accessible to your scientists as well, right? So that they have something decent to work with a low barrier of entry. And actually, it was also deep learning, so convolutional neural networks, right? It's not fully new, but it's actually one of the AI or machine learning methods which really delivered a breakthrough here. I think this is, I don't know. I think it happened like 5-6 years ago, and it's really working well. I would say it's one of the AI areas where we now really have this impact. I created an AI image of how such an application could look like. You know, a computer evaluating your experiments. Our tools look less crowded and cleaner to work with. So So what I said. How do you scale this up? You do your proof of concept, you create initial training data, you build your model, you validate it, it's working, great. So how do you scale? We need to automate capture, so robotized data capture, meaning automated image taking setups. This data needs to be uploaded, so this needs to be fully autonomous in principle. Then we have model predictions. We still do human-in-the-loop validation, and then we enter this into our experimental capture systems, right? So this is what the scientists in the past did after walking through the greenhouse. And if you bring this into an operational model, then you can continue to improve this, right? So actually from the human-in-the-loop validation, we get validated data back, so we can feed this data back into model training, and we continuously get better over time, which is pretty nice. So the upside here is very clear, right? We get much denser data. So one observation every 7 days, you can easily take an image every 5 minutes. You even can take videos, right? So your data density goes up. From that more dense data, you can derive additional conclusions. We can even predict additional endpoints in the same screens. Standardized quality, this is proven. And of course, you have less human labor because a lot of the tedious work is automated. Still, this is a this comes with a big change challenge, right? Because it's a different way of assessing. I mean, scientists now sit in front of the computer and validate computer vision model output. This is very different than walking through the greenhouse, right? And some people take this as a threat for their expertise. Others take it as an opportunity, right? So now you are AI enabled and you can do much more in much less time. But that change management is difficult, and you really need to enroll people into this new way of working. Different way of conducting experiments. I mean, greenhouse operations is changing. This can be perceived as a job threat as well, obviously. And actually, the most important point, doesn't sound like it, but was training data creation. Because for computer vision models to work, you first need to create initial training data, train your initial model, and once you have this, you can operationalize it. But actually, what that means is, for your existing measurement platforms, or if you want to introduce new assays, new measurements, you start with screening for creating training data, not with screening for project progressions. And initially, management hates this, right? Because it also says, you know, we have a new project, well, we don't work to progress compounds in that project. We first do work to improve our models. That's a really change in your ways of working, right? And this needs to be managed, and you need to go through this and prove that then later you are much faster and much better, potentially being slower at the beginning. And yeah, again, right, when you want to do the scaling, actually the change management is key. So I guess all of us have heard this many, many times. I myself have heard it many, many times. Still struggling at it, but we like to start with proof of concepts and technology. I still think this is good, right? You need to validate your technology before you start implementing. But actually, as soon as you have this validation, the first operationalization, the focus changes, right? So if the technology works and you bring it into operationalization, the change hurts. And this is unavoidable, right? You can, and this is also true for all the new upcoming AI stuff. You can't shortcut this here. If you really want to change your operating model, and I'm not talking about nice productivity improvements with, I don't know, scanning your emails with Microsoft AI or so. If you really want to change your ways of working, you have to go through this, and it will be painful, but you need to focus on that to get it right. So you need to enroll people first, and then with enrolled people, you can redesign your process, and if you do this, you get the full payout. And yeah, that's already it. So the conclusion is, right, I think you still need to scout technology. You need to prove technology is working before you go into adapting your processes and the design work there. However, do it with intention. Also here, you of course should only scout technology where you anticipate like value when you implement this in your operations. And then if you have a successful proof of concept, go into platforms, right? So that you bring something into operations that is easy to use for your scientists and change the process and people by design from the beginning as well. And if successful, actually you can get a lot of innovation payoff from this, because if you automate certain processes, you get richer data. The creativity kicks in once you have the first use case implemented, like we had this with phenotyping as well, right? Because now we are actually able to measure or predict completely different endpoints from the same assays we did in early screening in the past. So this is really changing the way how we can do our research process. And with that, I'm happy to take your questions, so thanks for your attention. And
thank you, Arndt. Any questions for Arndt?
everyone keen on coffee break?
Here's one. We got one here.
Could you please share a little bit more about the training data and the validation data? Because I know that this is a challenge that we are having, because in some cases the authorities are asking us to maintain both, and that it must be different, the training data versus the validation data.
So, I mean, how we start is, let's say you have a new essay, you need to start first to capture training data, meaning you need to label a set of images that you have, which is already a bit more complicated because you need to define the segments which are relevant and then do the labeling and so on and so forth. So then you do standard machine learning training. Of course, you do already model validation, like cross-validation and so on and so forth to measure your initial model performance. Once this is good enough, you put this into operations, right? But actually, we still have a human-in-the-loop evaluation, right? So we have an application that shows the model output overlaid with the pictures, and scientists still go through this and check, is the model output right or wrong? And if it's wrong, they either discard this from the experiments and label what was wrong. And actually, this human-in-the-loop validation, you again can take back into your training data later, right? But that's a different thing than the initial, let's say, cross-validation or train-test split for model training.
Magda. I think you might still be on mic, Magda. Yeah. Okay.
Could you share a little bit your experience on how you convince senior management to allow you to generate the training data? Did you create like a pitch deck and were you then held accountable to delivery on the promise in the pitch deck?
Well, I mean, luckily this is not only on me, right? So, I mean, we are on the IT side, we closely partner with our scientists who also develop these approaches. So I don't have a blueprint for that, right? I mean, this is a topic which is not super brand new, but we are still in operationalizing it, part of which also shows the challenge. But I think initially you need a leap of faith, right? I mean, you see a new technology, you need an approach that might work. So you need to identify a good use case, someone from the science side who has the skills to manage the technology initially, like training those models, and then you need management to convince management to take a leap of faith, do some initial investment and go there. And for the operationalization part, it's really bringing the first results. If you start to quantify that and you extrapolate it, of course, those are things that then help you to convey your message. So I don't know if this really answered your question. I think there is not a blueprint for that, but yeah. So this is how it worked in this example.
Thank you. So yeah, I had the same question. I thought that was how do you give yourself the time to have that what you termed as slow start? Yeah. But it's not a slow start, right? You're still doing lots of work, but the arrival of the I'm seeing stuff impact my science is slightly delayed. So.
Yeah, it still is a key challenge, right? I mean, initially we had our computer vision experts doing the first labeling of images themselves, right? Just to get going until we get to the point that really our biologists to do the assessments, do the labeling as part of their job. So this was not easy to get that transition done.
Yeah, you probably have to bribe them or yeah, something like that. Thank you, Arndt. Really good.
Thank you, team.